Welcome to this deep dive, where we'll be talking about SQL injection, why it's dangerous, and even see a live demonstration of how it works. Okay, so imagine being able to bypass your bank login without needing your password. That sounds pretty dangerous, right? You don't want others to get into your account without ever needing to know your password. Well, that's exactly what SQL injection is. It's a way to bypass security by essentially using snippets of SQL code to get past authentication. If you know what you're doing, you don't even need any special software. You can just do it on any regular page that's unsecure. But we're getting a little ahead of ourselves. What even is SQL? It's just a programming language that allows you to interact with databases using super simple commands. By using these commands, you can manipulate how data is stored within a server. Okay, so now that we know what SQL and SQL injection is, let's see an example of this. As you can see, here's an SQL line that an inexperienced programmer might use for authenticating on their website. So, let's dissect this. First, we can see the select all from the user's database. The asterisk here represents all entries, so this statement grabs all of the data entries within the user's database, which is probably the place where this person puts their information in. Next, this where clause tries to match the information we took from here and match it to what's written next, which is a simple input where we check the username and password. So, what this statement is doing is checking the user's database for any entries where the username happens to be $input and $input. For this example, I just happen to use $input to represent input that our user might give to our system. But what if our user decides to be sneaky and use this statement as their password? I'll let you take a look at this statement carefully, along with what it would evaluate to if we substituted $input with what this says. Alright, let's move on. So everything's pretty much the same. Here, we still see that we select users like we used to, but now the username and password are different. Since the expression says that 1 equals 1, and obviously 1 does equal 1, the OR statement in this will automatically become true, and you're in, right? The same statement can evaluates the same here, so I decided to show it here as well. Since it will evaluate based on anything, you eventually get access to what's here. So let's now do a demo of what we just did to get an idea of how an attacker might actually do this type of attack. Now, before we get started, I should preface this by saying that, along with any other type of hacking, SQL injection is illegal, and you should not try to hack into anything unless you're giving explicit permission to. What we're about to do is a lab from Portswigger, which means that we're allowed and even encouraged to try and hack into a mock system. This system is designed for SQL injections, so that's why we're allowed to do this. But don't do this anywhere, even if there are vulnerabilities, since it would be illegal. Okay, so we're currently on Portswigger, which is a website that, in addition to other types of attacks, will allow me to demonstrate how SQL injection works. As you can see, it looks like a basic website where we're just selling a bunch of pretty interesting things. If we want to get our account right here, we want to try and log into the administrator. So for our username, we'll try and use a really basic username for which is usually admin. And for our password, let's try and use what we learned from the slides, which is this. This should evaluate to true and make our password true, and we'll get in. So let's cancel this out. Type in admin, and for our password, we'll just paste in what we had learned and log in. And as you can see, we are in. Disregard this. Now we're in the admin account, and we can change the email, we can do whatever, we can update it, and we can cause havoc to this site. So with that, now we'll just move on back to the slides. So we were able to just get access into someone's website as a demo, of course. So what would the consequences for this imaginary person be? Well, code that isn't secured against SQL injections could risk giving access to threat actors, which is really bad. You don't want people to be seeing the sensitive information of another person, especially if said person trusts the website to keep their data secure, like banks. That might mean that customers would see you as a threat to their own data and wouldn't give you your business, which is never good for a business that runs exclusively on the internet and needs money. So, how can we prevent this? Warning, this is going to be a bit technical because of the nature of SQL, but I'll do my best to explain it clearly. First, parameterizing queries is probably the best way to do this, and it's essentially just making sure that the code you write is written in a way that sees the data passed in as actual data, not just something that can be injected into the script. Next, checking the user input and making sure that it isn't SQL in disguise is also really easy and can prevent a lot of attacks from happening in the first place. Lastly, enforcing the principle of least privilege is a great emergency feature to put in place. By only giving a database the permission it needs, even if an injection got in, a user can't do as much damage as they could. So it's a bit better for companies than just having no protections in the first place. If we want to look at this from the perspective of an enterprise business, I'll use the 4 risks that I've listed here. Strategically, SQL injections can lead to damage to the reputation of a business. Operationally, you need to turn off the systems and get the hacker out before they can do too much damage, which will make the business have to shut down for a bit, risking disruption of daily operations. You'd also be violating a lot of laws and regulations concerning consumer data safety, which you don't want to get in trouble with. And lastly, customers don't want to work with the business, which can give up their data easily, so you'd be losing out on a lot of business if this happened to you. So here's a couple of questions to let marinate in your head. As someone in cybersecurity, it's really important to keep these types of questions in mind when protecting data and assessing risks within a company. So take some time to really come up with your own answers to these. You can pause the video if you'd like right here. Okay, and lastly, if you're interested in continuing your learning about this, check out these websites. In addition to what you see on this slide, the place that I hosted a demo on is called PortSwigger. It's a really cool place that allows you to check out tons of vulnerabilities and how they work and even try them out, like what we just did. Just Google PortSwigger if you'd like to create an account and learn more. And with that, that's the end. Thank you guys for watching, and I hope you guys enjoyed the video.